Welcome to Session 8, Factoring and the Zero Product Rule. Today, you will factor out a greatest common factor before using another pattern. Factor trinomials and verify by expansion. And use the zero product property to solve quadratic equations. Watch the structure, not just the arithmetic, because each move must preserve the meaning of the problem. The visual gives us the central idea. The four regions represent the terms produced by multiplying two binomials. Factoring asks for the missing side labels that produce those regions. The middle terms must combine to the original linear term, while the corner product must match the constant. Use this first move. Move every term to one side so the other side is 0. Then, factor out the GCF. Then look for trinomial or difference of squares patterns. Worked example, GCF first. Factor 8x cubed 12x squared. Step 1. The coefficient GCF is 4, and the shared variable factor is x squared. Step 2. Divide each term by 4x squared. The remaining terms are 2x and minus 3. Step 3. Multiply back to verify both original terms. The final answer is 4x squared, 2x3. Check that it satisfies the original conditions and carries the correct units. Now it is your turn. Solve x squared plus 2x15 equals 0. Pause, write each algebra step, and use the next 6 seconds to finish your solution. Here is the modeled solution. The answer is x equals 3 minus 5. Find two numbers with product minus 15 and sum 2. Verify it against the exact wording before moving on. Session 8 recap. Move every term to one side so the other side is 0. Next, factor out the GCF. Then look for trinomial or difference of squares patterns. Then, set each factor equal to 0. Finally, check roots in the original equation and connect them to graph intercepts. A complete solution shows the reasoning, checks the result, and states what the answer means.